Yes, yes.
Sir, can you please upload that Monday, Tuesday, and Thursday's lecture, sir?
Yes, please upload.
Uh, yes, I'll do it today. There was a problem
Because our
yesterday.
midterms were there, so we were not like able to attend.
Okay,
That's why, sir.
okay, okay. I'll do it today.
Okay, sir.
Yeah, fine. I think we will start. Is this visible?
Yes, sir.
All right. So let us quickly recall what we did last time. So we have finished with functional dependence using Jacobian. Okay, two functions or three functions u, v, w are functionally dependent if there exists a relation between u and v. Okay, not only linear, it can be non-linear relation. But to determine whether they are functionally dependent or not, we find its Jacobian with respect to xy, and if it is 0, then they are dependent. If it is non-zero, then they are independent. So moving ahead in application of partial differentiation, next concept is errors and approximation using partial derivatives. So if z is function of xy and delta x delta y are small increments in x and y respectively, then delta z will be increment in z. Okay, so this incremented function z plus delta z is equal to f of x plus delta x plus comma y plus delta y. Now, if you do subtraction of 1 minus 2, you will get that increment delta z. All right, that is f of x plus delta x comma y plus delta y minus f of xy. All right. So f of xy. Now, the using Taylor's series expansion. This is f of xy plus delta x double f by double x plus delta y double f by double y and so on minus f of xy. Okay, this expansion is Taylor series expansion of this. Now, if you do this calculation, this f of xy gets cancelled. So delta z is delta x double f by double x plus delta y double f by double y. What we are doing is we are uh, neglecting higher powers of delta x and delta y here in this expansion. Okay. So approximately delta z will be double f by double x delta x plus double f by double y delta y. Okay. So delta y are small changes, or we can say error in x and y respectively. Then delta z will be error in z. Okay. So replacing delta x, delta y, delta z by dx, dy, dz. That means taking limit delta x tending to 0, delta y tending to 0, delta z tending to 0. We get dz is equal to double f by double x dx plus double f by double y dy. Okay. So this dz, dx, dy are called as actual errors in z, x, y respectively. Then dx by x, dy by y, dz by z are called as relative errors in x, y, z. And if you multiply by 100, so 100 dx by x, 100 dy by y, and 100 dz by z, are known as percentage error in XYZ respectively. Okay. So most of the time we will be calculating percentage error in XYZ. That means 100 dx by x or 100 dy by y. Uh, Such terms we will be calculating. Is the concept clear? Given a function z, we will differentiate like this, and then we find the error whichever is asked. Yes? Any doubt in this?
No, sir.
So just note down these two, three statements. Z is equal to f of xy, then dz is equal to da by f by da by x dx plus da by f by da by y dy. Okay. Where dz, dx, dy are called as actual errors in z, xy. And then second statement, dx by x, dy by y, dz by z are known as relative errors in xyz. And then you multiply by 100. So 100 dx by x, 100 dy by y, 100 dz by z are called as percentage error in xyz. Okay. So just write down these 3-4 statement.
Sir, could you scroll up a bit?
Fine. Or previous slide.
Previous slide, sir.
Okay. Okay. Only one thing that you don't know is expansion of f of x plus delta x comma y plus delta y in powers of delta x and delta y. That is Taylor's theorem for two variable function. Okay. Taylor's theorem for two variable function. Copied? Yes. Have you copied this slide?
Yes, sir.
Yes, sir.
Okay.
Excuse me, sir.
Yes.
Sir, how did they do that expansion f of x plus delta x y
That's
plus
what
delta?
That's what I said. This expansion is new for you. This is Taylor series expansion of two variable function. See, what we have studied is Taylor series expansion of f of x. But this expansion, this f of xy plus delta x into double f by double x plus delta y into double f by double y is Taylor series expansion of two variable function. Okay. So right now you write this as it is. Fine.
Yes, sir.
See, next term will be delta x square dabba 2f by dabba x2 plus delta y square into dabba 2f by dabba y2 and so on. Okay, that's what the series expansion. So we are neglecting those higher powers of delta x and delta y. Can you go ahead? Yes.
Yes, sir.
Okay. So here is the first example. A time t of complete oscillation of a simple pendulum of length L is governed by the equation capital T is equal to 2 pi under root L upon G. Find the maximum error in T due to possible error up to 1% in L and 2% in G. Okay. So now you can check that the errors given are in percent. Okay, so 1% in L and 2% in G. So obviously we need to find percentage error in T. Is that clear? Is that clear to everyone?
Yes, sir.
Even if it is not even if it is not mentioned that which error you want to find, because there are three types of error. Let me tell you. First one is actual error, then second one is relative error, and third one is percentage error. Okay. Now out of this, there is no mention of uh, type of error. Okay. But you can check that the errors given in L and G are in percent. Therefore, you need to find percentage error in T. Okay. Now, by this, okay, what we will have to do is we will have to differentiate that function with respect to x and then with respect to y, and then you have to write this expression. So you can see that t is function of L and G. Okay. So instead of direct differentiation, what I will do, I will apply log on both sides. You will understand why. So log t is equal to log of 2 pi, this L by G raised to 1 by 2. So if you apply log, it will be 1 by 2 log L minus 1 by 2 log G. Is this statement clear?
Yes, sir.
Yes, sir.
Fine. Now you can check that if you take a differential of each term, derivative of each term, so derivative of log t with respect to t is 1 by t dt. Okay. Derivative of log 2 pi is 0. Plus 1 by 2 as it is, derivative of log L with respect to L is 1 by L dl. Then minus 1 by 2 as it is, derivative of log G is 1 by G dg. Okay. Now you multiply by 100 to each term. So dt by t into 100. So 1 by 2 you can take out. So dl by l into 100 minus dg by g into 100. Now this term you know, dl by l into 100 is 1. Okay, because percentage error in l is 1. And dg by g into 100 is 2. Okay, that is given. So dt by t into 100 is equal to 1 by 2, 1 minus 2. Okay, okay, fine. Maximum. So if this is negative, so you need to find maximum error in t. If you take this 2 as it is, you will get 1 minus 2, that is uh, minus 1 by 2, but that will be minimum error. We want maximum error, that means when g is negative, this will become 1 minus 2, so 3. So 3 by 2, that is 1.5% will be the maximum error. Is it fine? Any doubt in this?
One minute, sir.
Yeah, I'll give you time to write, but any doubt in solution in any step?
No, sir.
Now you can check that applying log on both sides is going to help you most of the time. Okay, because differentiating with respect to L into dl plus differentiating with respect to g into dg will be the huge expression. Whereas if you apply log on both sides, that will be simple, and then you can differentiate with respect to that variable. See, our target is to bring uh,
Sir,
yes.
I understood that we have taken dl by l into 100 and dg by g into 100 as 1 and 2. So
Yeah.
you have written that so dt by d into 100 equal to half into 1 plus
uh,
minus 2. Why plus minus?
yeah.
Why not only plus?
Yeah, see, here it is minus, right? This middle sign is minus,
Yes, sir. Okay,
right?
sir. So that's why.
So,
Okay. That's why you
and
have
you
taken
want,
minus.
yeah, and you want maximum error. If you write that minus, so 1 minus 2 will be minus 1 by 2.
Yes.
That will be
Minimum
that will
error.
be minimum error. Okay. So when g will be negative, at that time you get maximum error. Fine.
Got it, sir.
Yeah. Okay. Now, whenever your formula is in terms of multiplication of division of terms or variables, you apply log on both sides and separate out the terms. Okay.
Excuse me, sir.
Hi, yes.
Sir, in the step that says differentiating, this is
Huh.
instead of that, can we say that this is partial differentiation?
No. This is differentiating means total derivative of each term.
But we are differentiating each term and like we are not differentiating with respect to one single term on both
Yeah,
sides. We are
we are differentiating with respect to that variable only. So taking differential of each term, taking change in each term.
understood, sir.
Yeah. Copied? Can you go ahead? Okay. So in example 2, the power dissipated in a resistor is given by P is equal to E square upon R. Find by using calculus the approximate percentage change in P when E is increased by 3% and R is decreased by 2%. Okay, I read it again. The power dissipated in a resistor is given by P is equal to E square upon R. Find by using calculus the approximate percentage change in P when E is decreased by 3% and R is decreased by 2%. So again, you can check that the terms are in multiplication or division. So applying log on both sides is going to help you. So P is equal to E square upon R. Apply log on both sides. So log P is equal to 2 log E minus log R. Okay. Now take differential of each term. So 1 by P dP is equal to 2 by E dE minus 1 by R dR. All right. Now multiply by 100. So 100 dP by P is equal to 2 into 100 d E upon E minus 100 dr upon R. Now E is increased by 3%. So percentage error in E is 3 and R is decreased by 2%. Therefore percentage error in R is minus 2%. Okay. So 100 dP by P is equal to 2 into 3 minus this minus 2. So 6 plus 2 becomes 8. So 8 percentage is the error in P. Okay. Do you understood why this minus sign is here?
Yes, sir.
All right.
Yes, sir.
So note it down.
Sir, please wait for 2 minutes. Okay.
Okay. Done?
Sir, 1 minute, sir. Yes, sir.
Okay. So moving ahead in for example 3, it says that in estimating the number of bricks in a pile which is measured to be 5 meter into 10 meter into 5 meter, count of bricks is taken as 100 bricks per meter cube. Find the error in the cost when tape is stretched 2% beyond the standard length. The cost of bricks is 2000 per 1000 bricks. Okay. So obviously volume is given by x into y into z, length into breadth into height. Okay. So taking log on both sides, so log v is equal to log x plus log y plus log z. So differentiating dv by v, so 1 by v dv is equal to 1 by x dx plus 1 by y dy plus 1 by z dz. Now multiplying by 100, 100 dv by v is equal to 100 dx by x plus 100 dy by y plus 100 dz by z. Now this error in each length is 2%. Okay, length, breadth, or height. So it is 2%. So therefore, substituting these values as 2, so error in volume is 6. Okay, so so delta V is equal to V upon 100. So V is equal to 5 into 10 into 5 upon 100. So which turns out to be 15 cubic meter. So now number of bricks in delta V is equal to 15 into 100. Okay, because it is given that the counts of bricks per meter cube is 100. So number of bricks in delta V is equal to 15 into 100, which is 1500. Therefore, error in that cost will be 1500 into 2000 upon 1000, and which is 3000. So the loss to the seller of bricks is 3000. All right. In doubt in this? Yes. Any doubt in this?
No, sir.
Others? Any doubt in any step?
No, sir.
No, sir.
So just note it down. Can you go ahead? Have you copied?
1 minute, 1 second, sir.
Okay.
Done, sir.
Okay. Obviously, this is again on the same line. I think I should leave it to you. Let us take it quickly. What error in common logarithm of a number will be produced by an error of 1% in a number? Okay. So consider x is any number and y is equal to log x. Okay. So 1% error is given in x. You want corresponding error in y. So dy is equal to 1 by x log x dx. So delta x by x into 100, if you multiply by 100 and divide by 100, so delta x by x into 100 upon 100, so log to the base 10 into e. So this is 1, delta x by x into 100 is 1, so 1 by 100 log to the base 10 e, and substituting these values, so 0.00434229 is the error in y. Okay, so please take screenshot of this. We'll go ahead.
Sir, you are going to send this PPT, right?
Yes, obviously. Uh, we'll skip this.
Sir,
Yes,
so when is that PPT submission?
5th November, no?
Sir, but we are having exams on 6th November.
Then you can submit by 4th. Okay. I gave you enough time to prepare everything, so I'm not going to listen anything from your side. So if there is exam on 5th, you can submit by 4th. Okay. Presentation, we'll see how to plan presentation, but submissions will be EOD of 5th November. Okay. uh, we'll look at this problem of approximation and then we'll stop. Find the approximate value of 0.98 square plus 2.01 square plus 1.94 square whole thing raised to 1 by 2 using theory of approximation or using partial derivatives. Okay. So first point is you need to approximate this thing using some function. Okay, so here function is x square plus y square plus z square raised to 1 by 2. This is your step 1. What is step 1? Approximate the given problem by a function f of xyz, and in this case it is x square plus y square plus z square raised to 1 by 2. Okay, now take x, y, z, which are numbers close to this and which are actually integers. Okay, so in this case x is 1, y is 2, and z is 2. Okay, you can check that 0.98 and the nearest integer is 1. Here 2.01 nearest integer is 2 and 1.94 nearest integer is 2. Okay, so x, y, and z are 1, 2, 2. So therefore, delta x or dx will be 0.02, that is negative. Then dy is 0.01 and dz is 0.06, and that is negative. Is the second step clear? This is dz, not dx. Okay. Any doubt in this?
No, sir.
Okay. Dx is negative because this is 0.98 and your x is 1. Okay. So 0.98 minus 1. Okay. This is x1, x2, x1, y1, z1. These are x2, y2, z2. So x1 minus x2. So that will give you dx, dy, dz के values. Now, dabba f by dabba x is 1 upon 2 root of x square plus y square plus z square into 2x. So that 2 gets cancelled. So dabba f by dabba x is x into x square plus y square plus z square raised to minus half. Similarly, dabba f by dabba y is y into x square plus y square plus z square raised to minus half. And dabba f by dabba z is equal to z into x square plus y square plus z square raised to minus half. Any doubt in these partial derivatives? Yes, any doubt in dabba f by dabba x, dabba f by dabba y, and dabba f by dabba z? Please respond.
Sir, I couldn't understand this part.
Which one?
So this is dabba f by dabba x.
Okay, see, this is a function x square plus y square plus z square raised to 1 by 2. Take its derivative with respect to x. What is its derivative with respect to x? What is derivative of under root x square plus y square plus z square? Tell me.
So 1 upon the function, I mean x square plus y, root of x square plus y square plus z square.
Into derivative of this x square, no?
Okay, yes, sir. Yeah, 2
So
gets
that will
okay,
be,
sir, I got it.
so that is 2x and that 2 gets cancelled. So therefore it is x into x square plus y square plus z square raised to minus half. Others, is this fine?
Yes, yes, sir.
Okay. Uh, then we calculate error in df, error in f, that is called as df. So df is equal to dabba f by dabba x dx, dabba f by dabba y dy, and dabba f by dabba z dz, summation of these three terms. Okay. So dabba f by dabba x is not known to you, dx is known to you, dabba f by dabba y is here, dy is also known to you. Then you dabba f by dabba z is z into x square plus y square plus z square raised to minus half, and dz is also minus 0.06. So substitute these values. So x square plus y square plus z square raised to minus half you can take out. So you will have x dx plus y dy plus z dz. Okay. Now x is 1, y is 2, z is 2. So substitute these values. So 1 plus 4 that is 9. So 1 upon under root 9. So that is 1 by 3. Is this fine?
Yes, sir.
Yes, sir.
Okay. So 1 by 3. Then x into dx. So 1 into dx, that is minus 0.02, plus y into dy. So 2 into 0.01, that is 0.02, and z into dz. So 2 into minus 0.06 is minus 0.12. Okay. So df is minus 0.04. So df is f of x1, x2, x1, y1, z1, or f of xyz minus the given thing. Okay. Or df is equal to f2 minus f1 in some sense. So f2 is this and f1 is f of 1, 2, 2. So f of 1 to 2 is 3 and df is 0 minus 0.04, therefore 2.96 is the answer. Do you understand this third last step?
Yes, sir.
Yeah. Others, this is important. One has to understand this. If you have any doubt in this third last step, please ask me.
Sir, can you repeat it again?
See, df is equal to f2 minus f1. Okay, difference in values of f, right?
Yes, sir.
Is this fine? df is f2 minus f1, like dx is x2 minus x1.
Yes, sir.
Okay, so df is f2 minus f1, where f2 is this 0.98 square plus 2.01 square plus 1.94 square raised to 1 by 2, and f1 is f of 1 to 2. Okay, values of f at these values 1 comma 2 comma 2. So therefore f2 is equal to f1 plus df, out of which df is known to you. F of 1 comma 2 comma 2 you can easily calculate. So 1 square plus 2 square plus 2 square, that is 9 raised to 1 by 2, which is 3, right? So 3 plus minus 0.04, because df is minus 0.04. Is that fine?
Yes, sir.
Okay. Anybody else would like to ask? Please respond.
No, sir.
Okay, fine. Okay, so as an practice problem, you can calculate this 4.85 square plus 2 into 2.5 cube raised to 1 by 5. Okay. Uh, so next is maxima and minima, which we'll take in next lecture. These are some practice problems. Uh, just tell me, how do you solve this last problem? For time being, this you can take this delta as 2%. Okay. See, question is, the focal length of mirror is given by formula 1 by v minus 1 by u is equal to 2 by f. If equal errors delta are made, so for time being you take it as 2. In determination of u and v, show that the relative error df by f in the focal length is given by 2 into 1 by u plus 1 by v. Okay. My question is, applying log on both sides is going to help you or not? Yes, anybody?
Which example?
This last example, the focal length of mirror is given by a formula. What you have to show is relative error df by f is delta into 1 by u plus 1 by v. Okay, so I told you that for time being you take delta as 1 per 1 or 2.
Sir, applying log will help.
How?
Sir, we can take minus of the log and take the f, u, and v in the numerator, and then we can differentiate.
What is log of this left hand side? Log of 1 by v minus 1 by u. How do you separate it?
Oh, no, sir. Sorry, sir.
Yeah.
It won't be.
Okay.
Sir,
So
we can split the 2 upon f as 1 by f plus 1 by f and then take it to the other side and then differentiate.
okay. Let me tell you, for such example, you are going to differentiate directly. See, what you want is df upon f in picture, dv by v in picture, du by u in picture, right? Because that is given to you. Error is delta in u and v, and you want df by f, relative error df by f. So if you take a differential of each term, what is differential of 1 by v with respect to v? Yes.
Minus 1 by v square.
Minus 1 by v
Yeah, minus 1 by v square into dv. Then minus as it is. What is differential of 1 by u?
minus 1 by u square du by dx.
Du by dx, there is no role of x,
Yes,
only
sir.
du.
I wanted to.
Yeah. Then what is differential of 2 by f? Minus 2 by
Minus
f
2 by f
square
square.
into df. Okay. So now you adjust the term and you will get this focal length as delta into 1 by u plus 1 by v. Okay. Then this second last example, tell me your function. Evaluate 4.85 square plus 2 into 2.5 cube raised to 1 by 5. Yes, please. Tell me a function. What is f of xy in this case?
X square plus 2y cube to the power 1 by 5.
Okay, x square plus 2 I cube raised to 1 by 5. What is x? What is y? X is 5. Y you can take as 2 or 3. Okay, it is up to you because it's 2.5. So y you can take as 2 or 3. Fine. What is dx? What is dx? Minus 0.15. All right. And what is dy? If you are taking as 2, then 0.5. If you are taking as 3, then minus 0.5. And then you apply that theory of approximation. All right. May I stop sharing this?
Yes, sir.
Okay. So we'll take this maxima and minima wala part on Monday. Fine. Any doubt?
sir.
All right. All right. So we'll stop here then. Thank you. Before you
Thank you,
leave,
sir.
just write down
Thank
your
you,
name
sir.
and roll number.
Thank you, sir.
Thank you, sir.
Thank you, sir.